Okay, so the first question we had was, what is the fraction in Costa Rica's flag that is red? And what is the fraction in Costa Rica's flag that is blue? Now what you had to notice was that there's actually two parts of red here. There's double red. So if we're going to look at the amount of red, and we have to imagine that this line is twice as thick as all the others, we have to look at how many lines do we have in total. 1, 2, 3, 4, 5, 6. We have 6 lines in total, and they're all equally thick, so they've got the same fraction. So the number of red that we have would be 2, 6, which we're not allowed to leave it like that, we have to simplify it, divide top and bottom by 2, and we would get 1/3 of our flag is red. Blue, we also have 2 parts that are blue, 2, 6 in total, giving us 1/3 of our flag was blue. Then it says, we've got a matrix here with blue squares and white squares, and it's wondering how much of this shape is the fraction of blue squares. We'll take questions at the end. We'll take questions at the end because I'm filming this. We'll take questions at the end, thanks. We have 2 blue squares in a section of 8. So we either have, we can write it as 2 out of 8, and we have 3 sections with 2 in every 8. Or we can say that we have 1, 2, 3, 4, 5, 6 blue sections. Out of how many do we have in total? We have 6 by 4. 6 by 4 is the number of total squares, so we have 6 out of 24. Or if we leave it like this, it's even easier, because 6 divided by 6 is 1. So it's 1/4. And 2/8 is also going to give us 1/4. 6/24, divide top and bottom by 6, that will also give us 1/4. It doesn't matter which method we use, but we should always get that there are 1/4 of our squares are blue. So that's the answer for that one, 1/4. Then for the next one, we have expand the fraction 3/4 so that you get different denominators. You have a fraction 3/4 and you have to expand it. Was it 4 different ones? The denominator has to, in the first one, be 12, in the second one, 20, in the third one, 32, and in the fourth one, 48. So we need to remember what the term denominator means. The denominator is the bottom number in our fraction. We need to take 3/4 and turn it into the equivalent fraction where the denominator is now 12. So if we set it up like this, it's quite easy to do, because we think, what have we multiplied by or divided by to go from 4 to 12? By 3. So we have to do exactly the same thing with the top fraction, multiply by 3. So we get that this 3/4 is equivalent to the fraction 9/12. The next one, the 3/4 denominator now has to turn into a 20. How can I do that? If I multiply 4 by 5, I would get 20. I have to do the same thing on the top as I do on the bottom. So 3 times 5 would give me 15. So I'd get its equivalent to the fraction 15/20. The next number, I have to have my fraction 3/4. My denominator now has to be 32. How could I go from 4 to 32? If I multiply 4 by 8, I get the answer 32. If I multiply the denominator by 8, I have to multiply the numerator by 8. And 8 threes would give me 24. So this is equivalent to the fraction 24/32. Okay? Now, last one, 3/4. Now has to turn into the denominator 48. How can I go from 4 to 48? Multiply by 12, I get 48. If I multiply the denominator by 12, I have to multiply the numerator by 12. And 3 12s are 36. So my answer here would be 36/48. Okay? That was that one. Then we had to simplify the following fractions to get them in the simplest possible form. Sometimes this could be a trick question. They could give us fractions that can't be simplified. And you can never, if it's in fraction form, it's not a fraction if it's got a decimal point in it. It's not a fraction anymore, it's a division sign, okay? So in order for it to be a fraction, there has to be no decimals. So the ones we have here are 8/12. For B, we had 6/24. For C, we had 14/56. And for D, we had 18/54. And we got big fractions here, and we can actually fairly easily see that we can simplify them. This one, we could divide top and bottom by 4. 8 divided by 4 would give us 2 on the top. 12 divided by 4 would give us 3 on the bottom. And it doesn't matter here if you don't realise straight away that it can be divided by 4. It could be that you decided, okay, I can see that they're both even numbers, so I'll divide top and bottom by 2. You would then get 8 divided by 2 is 4, 12 divided by 2 is 6, but now I've still got 2 even numbers, so I'll divide by 2 again because I'm not finished yet. And you still will get the same answer, 2/3. So it doesn't matter how many steps you have to do it in, just continue dividing until you can't simplify it anymore. 6/24, you could first divide by 3 and then by 2, but the easiest way is to divide straight away by 6, realizing that both 24 and 6 can be divided by 6. 6 divided by 6 gives us 1 at the numerator. 24 divided by 6 gives us 4 in the denominator. So our most simple form of this fraction is a quarter. 14/56, well, if I know my times tables well, I know that 7/8 are 56 and 2 7s are 14. So I can see quite simply here, I divide my top and bottom by 7. Start there. 14 divided by 7 goes 2 times. 56 divided by 7 goes 8 times. Oh, I'm not ready here because I have 2 even numbers. So 14 must have been a factor of 56 actually, which you could have worked out because double 14 you get 28, double 28 you get 56. But it doesn't matter, we just carry on one more time. Divide 2 by 2, it gives us 1, and 8 by 2, it gives us 4. So 14/56 looks like a really complicated fraction, but it's actually the same as a quarter. 18/54s, well, 2 9s are 18. 6 9s are 54, so we can divide top and bottom here by 9. 18 divided by 9, divide the numerator by 9, we get 2. Divide the denominator by 9, we get 6. Again, we're not allowed to finish here because it's not the most simplified form. We have to continue dividing. We have 2 even numbers. 2 divided by 2 is 1. 6 divided by 2 is 3. So we get a third there. So these are the most simple forms of all of those fractions. Then we were told that the following fractions we now have to put in decimal form. We have to show that we're not only good at manipulating fractions, expanding them and reducing them, but that we can also convert from fraction to decimal form. And they've given us the following fractions: 2/5, 3/8. Then we have 2/25, and we also have 2/50. And it's a nice mixture here because you've got to use different techniques to do this in the simplest way. 2/5, I think the simplest way is to multiply top and bottom by 2, because then you get 4/10, and we know that 4/10 is the same as the decimal point 4. 1 0 down here means we move the decimal point 1 place back, 0.4. 3/8, we actually should just do the division here. 8's going to 3, 0 times, 3 left over, decimal point in here. 8's going to 30, 8, 16, 24, 3 times. 8 3s are 24, we had 30, so there's 6 left over. 8's going to 60, well 7 8s are 56, We've got 60, so there's 4 left over. We've only used 56 here. We had 60, there's 4 left over. And 8 into 40 go 5 times. So we get the decimal 0.375. And we can convert any fraction into any decimal by simplifying first and then just doing the division. This one is much easier if we don't do that, because we're not very brilliant at our 25 times tables, are we? What the easiest way here is to multiply top and bottom by 4. If you do that, you get 8 on the top. The reason we're doing it is we're trying to get factors of 10 or 100 or 1,000 down here, because here we get 8 100ths. And that's really easy to work out the decimal. 2 zeros down here means we move the decimal point 2 places back, so we get 0.08. 2 places back, 1, 2. Putting the decimal point there. 2 50ths, well, if I multiply 50 by 2, I get 100 again. So I'll do the top one by 2 as well. So we get 4 100ths, which again, move the decimal point 2 places back, 0.04. 1, 2. When we're dividing by 100. So that's the easiest way, I think, to convert all of these fractions into their decimal equivalent. Now we had some adding of fractions. And we have first some really nice simple ones where the denominators are the same. So we had add 2 fifths and 2 fifths. And that's quite easy, because we all know how to add fractions now. We cover the bottom number and say 2 plus 2 is 4. And then we do nothing with the bottom number. We never ever add the bottom number, do we? We're counting in fifths. So the number of fifths that we have is 4 fifths. If we were to have a pizza, here are 1 fifth, here's 2 fifths, here's my 3rd fifth, and here's my 4 fifths. If I was to add up how many, well, it's not very well drawn, is it? Let's pretend. Here's a pizza split up into fifths to that. That, and here's another pizza split up into fifths. Okay? I tried to eat all of this pizza, but there were 2 pieces, so all of these I ate. There was 2 pieces of my pizza left over. Okay? And Arvid tried to eat all of his as well, but he couldn't either, so he had 2 pieces left over of his. How many pieces of pizza are left? Well, my 2 fifths plus Arvid's 2 fifths are 4 fifths of pizza. We haven't suddenly split them up into tenths. We are counting in fifths, we continue to count in fifths. So the bottom number never changes in fractions, only the top number. Then the next one was to have 5 6 and add 1/6 to it. And it did tell you that you have to simplify. Well, 5 6 and 1/6. 5 plus 1 is 6. The 6 stay the same. We have 6 sixths, which we're not allowed to leave like that, because 6 divided by 6 is, of course, 1. And the last one was, of these, was 4 sevenths plus 4 sevenths. 4 plus 4 is 8. What are we counting in? We're counting in sevenths. So the answer is 8 sevenths, which we're not allowed to leave it like that. It's a top-heavy fraction. 7 goes into 8 one whole time with 1 left over. So we would simplify that down to the term 1 and 1/7. And that was those ones. Then we had some fractions where they're checking that you know that you have to have the same denominator to add or subtract fractions. So now they're giving you some with different denominators. The first one they asked you to add was quite simple. 1/2 plus 1/8. You can't do anything with those fractions because they don't have the same number on the bottom. So you have to make it so that they have the same number on the bottom. If you multiply 2 by 4, you'd get 8 down there. If you multiply the bottom number by 4, you have to multiply the top number by 4. That changes our half into 4/8. Is that the same thing? Well, yeah, if we think here, here's half a pizza, okay? If we were to change this pizza into 8s instead, First split it up into quarters, and then we'd split it up into eighths. So, here are 4/8 of my pizza. Okay, so a half is exactly the same amount of pizza as 4/8. So this is what we're doing. Then we can add our 1/8 to it, and now we have the same denominator on the bottom. So now we're allowed to add. 4 plus 1 is 5, and we're counting in eighths of pizza. Can we simplify it anymore? No, we can't. So that would be our answer, 5/8. The next one that we have after that is we have 2/3 should be added to 1/5. Now it's not so easy. Now it's not just to multiply one of them. We have to multiply this one by 5 and this one by 3. So we multiply by the opposite. Why do we do that? Because 3 times 5 would give us the number 15 on the bottom. And 5 times 3 would also give us the number 15 on the bottom. So it's the easiest way to get the same number on the bottom. Okay? If I multiply this one by 5, I have to multiply the top one by 5. So my 2/3 is equivalent to the fraction 10/15. And my 1/5 is equivalent to the fraction 3/15. Now I have the same denominator. I can add my fractions. 10 plus 3 is 13. 13 what? 13/15. The bottom number stays the same. So that's how we add fractions with different denominators. We make them into the same denominator. Notice that I multiplied this fraction here by the number that was down there on the bottom. And I multiplied this fraction here by the number that was down there on the bottom of the other fraction. So we're cross-multiplying, we call it, when we multiply this bottom number by that fraction and this bottom number by that fraction. Okay, that gave us 13/15, which we couldn't simplify because 13 is a prime number. Then we have C, we have 3/4 plus 1/5. And again, we cross-multiply. Multiply this 5 by this number here. And we multiply this 4 by this number here. 3 5s gives us 15. 4 5s gives us 20. 1 4 gives us 4. And 5 4s gives us 20. So now we have the same number down here. So now we're allowed to add. 15 plus 4 gives us 19. And what are we adding in? We're adding in 20ths. So we have 19/20 as our answer. Okay, we're almost done because the next question was how much do we have left if it's 900 meters to go around the whole track? And we have started here and we've gone 3/4 of the way round. 3/4 of the way round means that we've got 1/4 left. So we want to know what is the distance left. So what we're really trying to find out is we're trying to find out what 1/4 of 900 meters is, because we've only got 1/4 left. So it's easier to work out 1/4 than 3/4 and then subtracting that from 900. So I think this is the easiest way. So what do we do then? We just do 900 divided by 4. 4 goes into 9 2 times, 1 left over. 4 goes into 10 two times, 2 left over, and 4 goes into 20 5 times. So there's 225 meters left when we've gone 3/4 of the way round. That's how much of a distance we have to go left.